responsible for binaries for maps, data, and like problems with maps on R, so much time. So I'm going to talk about Scalable, collaborating with the R.
Thank you, Ira. In fact, as Ira was saying, all the binaries for the world in R is now from in the building 275. That's my office. That's the building machine that actually produces all the binaries. So if you have any problems, you know where to go. So yeah, I want to talk about R Cloud. So it's mostly work. In fact, yesterday actually was the 8th anniversary of R Cloud. I'm not sure how many people heard about it, but it's been around for quite a while. And it's essentially literally a collaborative environment for visualization and data analytics that we designed many years ago, and we've been actually using very extensively at AT&T for the data analysis. And it's it's all open source, so anyone can actually use it. So the whole motivation really was, the long story really is that I've been working at the statistics research department at AT&T, and we've been doing a lot of data analyses, developing tools, and so on. And whenever we did any kind of analysis, which involves all this big, data science pipeline, at the end of it, you produce the results, you give it to someone, and they're happy, you're happy. But then someone comes back 6 months later and says, "Hey, you did this cool analysis for someone. Can you do? It's sort of similar to what I want. Can you do it again?" And then you have to remember, what were the machines where I did run it? Did I keep enough nodes that I can actually rerun the analysis? It does tie into reproducible research, what we've heard about today. And the answer usually is no. It's a lot of work. So we wanted to have something where you can actually do all of this in one platform. And the different pieces are actually quite complex, right? You can all the importing, cleaning, that doesn't necessarily have to be R, can be different systems. Then the visualization and modeling we have a good handle on as statisticians usually. But then you also have to communicate it to people. And we do have the tools now in R, so it's all nice. One thing that is kind of missing usually, is that actually a lot of times in the real world, it's more people working on this. It's not just one person doing this entire thing. It's actually different people doing maybe the first part of it, different people talking to, and so on. So we wanted something where you could actually do all of this, but share parts of the process or have different people work on different parts of the process. So we want collaboration, we want reusability. So if I did any kind of processing of a particular data set, I want my colleagues to be able to take that and build on top of it and just do a new analysis maybe, or new models, or just modify things, or even take the visualization that I did and run with it and so on. So the whole idea was pretty much to push the data and the analytics sort of in the cloud. So the cloud in our cloud really was meant sort of like iCloud. So that means you just don't care where you actually run the analytics. You don't care where the files actually live. You just care about having access to all that system from anywhere, whether it's on your tablet, on your computer, from work, from home, wherever you are. So you don't care where and how. So the results are just URLs you can send to people, but also when you develop it, it's all in web-based. Nice thing about that as a side effect is that it solves the scalability problem in some sense, because it's only a matter of, you can run it on your local laptop, and then everything is just on your laptop, and it doesn't matter that it's web-based. Just like our studio, it's actually web-based no matter what you do, but you can't see it usually. And in the same sense, you can run R Cloud on your laptop, or you can run it on a huge cluster, and it will scale, and it will use all the computing power that you have there. And for you as a user, nothing really changes. You're just using it the same way. And also the other fundamental thing is everything you do is always essentially a Git repository. So anything you do is version control. And it's web-based, and that means we also want to allow collaboration. So if you have someone else, they should be able to see all your stuff. They should be able to just fork things, just like on GitHub. You just say, I like this project, I just want to modify it. So you just go in there, you fork it, and so on. So I want to show you a little bit, a little demo of R Cloud. Let's see how this works. And in fact, we do have actually a website. There's a public version. You go to rcloud.social. The thing is, it's actually hosted on AWS in the US. So from here, it's really slow because it's 250 millisecond round trip just to get there. So that's why I actually spin up an instance here so that it's a little faster. But anyway, so essentially, you just what you see is just essentially a console like you would be used to. So you can do the usual things like just type any code. You can do any kind of plots, and you can do, and it's sort of all in this sort of notebook paradigm. You can even do a lot of stuff, like if I can do demographics, then you see all the output essentially here. And everything you do, like I said, is version controlled, so you can actually look at this and see these are all the different versions of every single thing that you did. So you can go back to a version, you can revert, you can fork your work, create a new notebook based on this one. You can, even someone else can do it. The other thing is you can share things easily. So if you click on this button here, it essentially just gives you a URL that you can give to anyone else, and it will just run the analysis. So it will show you exactly the same results that you've seen. So someone can just look at it. And this is really how we actually collaborate quite easily, that you just do some work, you want some of your colleagues or even your boss just look at it, you just send a link, they can do that. And if they can just look at the results, but if they want to change it, they can just click on the link here and they get into the edit mode and can actually run things interactively, can change things, can look at residuals and do other things, that you would want to do. Maybe the other thing to note is that we support what we call assets, which is essentially something you could think of it as like side files that you have attached to the notebook. So you can, again, I'm just being silly here, but you can just execute code just like you would from, essentially you have an editor and you can change things here and run it here, and it's part of the notebook. It's also version controlled and all of that. We support actually multiple languages, so R is the default. R is where everything started, and I'll go into details sort of why, performance-wise, why R is actually the first-class citizen. But we do support anything that's supported by Jupyter kernels. So we support Python. We have some native stuff like a shell, but pretty much any Jupyter kernel you can load in here and use in the cells. You can mix and match cells within a notebook, so you can use Python, R cells, and Scala, or whatever else you want. Other things, for example, that's important probably is search. So like I said, let's search for Python. I do have a notebook here that, nope, maybe I don't. Let's see. And also we support Markdown. So for example here, this is just sort of documentation that shows things. And then the other cells here are Python. So what it actually does behind the scenes, it starts a Jupyter kernel and then it runs Jupyter and combines the results in the cells here. Maybe one more thing before I go to the details is we also support Shiny, so you can actually, and actually there are some other ways you can do visualizations, as I'll talk about later, but among other things we support Shiny. The only difference is instead of having these separate files, having to run it through the server, what you do is you actually just put it in your code here and you just wrap it with rCloud Shiny app, and then you have the UI piece. And then you have the server piece, just as two separate functions in R, and that's it. I mean, everything else is just the same. So you can, and then you can just, when you view this, instead of running the code and running the cells, you're actually going to get a Shiny page that actually runs. The session becomes the server, and it runs the interactivity. So you can do the usual things that you can do with Shiny directly from rCloud. So let's go back. How does this all actually work? What's the magic behind it? So really the way this works is the user has just a browser. The browser connects to an rCloud server, and you can have multiple of these. They can be load balanced, so you can keep scaling and so on. We actually use a WebSocket connection to keep an active session alive, and then that server then can do a bunch of things. It can talk to big clusters. I won't go into that. There is a whole separate, there's a separate bunch of packages that allow you to do really high performance things on terabyte scale data sets, but that's how you talk to computing clusters. But an actual R Cloud server itself will then talk to the storage where all the notebooks are stored, essentially the Git repositories that I talked about, and also has a bunch of metadata that has things like, how popular are certain notebooks, did people star notebooks, you can actually search on these things or sort on these things and so on. So next bits are maybe a little technical, so I'll do quickly over some of them. So this is one of them, is we were kind of really focused on making sure that all this is very secure and scalable, because we wanted this to be usable not only just on a laptop, but also on big distributed systems. So essentially we use separate processes for the actual sessions that people run, and any kind of scripts that you want to serve. So in fact, you can just use arbitrary R scripts and make them run as web services. Technically, it's all essentially, everything happens over HTTP, so you only need one single port, which means this is really easy to deploy. It's easy to also from a security point of view, because you only need to open one port. It uses WebSocket upgrades to make that happen. We support parallel connections, so if it scales, you can have multiple users, you can spread them across servers, and so on and so on. And one of the really cool things, I think, with where R Cloud is unique to many of the other solutions, like Jupyter or RStudio, is that we have essentially a transparent R and JavaScript interface. So you pretty much any JavaScript function can be exposed as an R function and vice versa. And even allows recursion in the sense that you can pass an R function to JavaScript and JavaScript will run it, and vice versa. So you can pass a JavaScript function to R and R can run it. So we do all the marshalling of objects and all the complicated things. What this really gives you behind the scenes actually is that means you can pretty much use any JavaScript visualization natively directly from R Cloud without any special, no one needs to write any special code or bindings for that code. You can just call it directly. And depending how much time I have, maybe I'll give a just very quick demo of that. So essentially, if I go here, so if you want to run JavaScript from R, I'm just including this asset here, which is just test.js, and essentially all it does is just defines a function in JavaScript that just takes a parameter, issues an alert, and then calls a continuation, essentially, because JavaScript is not synchronous, so when you call a function, it doesn't wait until it's returned. It actually has to explicitly say, hey, this is what I want to return. So what this continuation is what returns the result, and this is the action. So I can essentially inject, register that function in R, and in R, it literally is just an R function. The implementation itself knows what to do with it, but in practice, what it means is you can just run the R function, and it just calls exactly the JavaScript code, and comes back, once I click OK, it comes back with the result that the JavaScript function had. So this is the building block for anything arbitrarily complex. This example just proves that you can do the same thing by passing functions. So you can actually pass an R function as a JavaScript function on the other side as well, so that when I run this, I can register an R function here, which just says print clicked, and that function can be registered as a callback to a JavaScript code that actually requires a JavaScript function. So that's pretty much what makes it so flexible. There's a little bit on security that I will probably skip. The nice thing is that everything is just encapsulated as a gist, which in practice you can use either GitHub as a backend. That's in fact what I'm doing in this instance. So when I actually go back here, so for example, when you saw this, you can actually see that this notebook here, you can actually open it in GitHub as a gist, and you see this is what it actually is. It's literally just a bunch of files that are called part 1, 2, 3, and so on. These are the cells. There is the asset. So it's all completely accessible. You can check it out using Git and so We also have implemented our own backend, so you don't have to rely on GitHub. You can use your own server or use local Git repositories on the machine itself. The other thing is that's kind of nice is you can scale this in any way, shape, or you want. You can just make it into a Docker container. In fact, we have a one-button click where you just click on the button, and all it does is, actually someone was earlier talking about the idea, which is it just collects all the dependencies, generates a Docker image, and just exposes the port, so that now you have a full, your application is completely deployable just by a single Docker image. You can also make it just on a single machine, or you can deploy it in a big environment when you have multiple users and you have authentication and all bells and whistles. So it works in situations like that where you have a lot of users. I was alluding to the support for visualization, that because of these direct bindings to JavaScript, it makes it really easy for people to actually write bindings to other visualization, especially interactive visualizations, because you can really interactively go between R and whatever package you have. We have dcplot, RC leaflet, and other libraries. You can mix and match regular R output with just specific HTML output, so you can just inject HTML or JavaScript code into the notebooks as you go. And it's really easy to build dashboards. Like I was saying, we support Shiny and HTML widgets. We also have actually something that some colleagues at AT&T developed, which is called RCAP, which allows you to do a drag and drop design of dashboards, and you just specify what are the underlying, what's the underlying R code, and you can just embed these things in arbitrary other web pages. So if you had a web page and just want some piece of it to be dynamic using rCloud, you could do that. As I was saying, rCloud has been around for a while. So what we did recently, we extended the search capabilities, so you can search by language, by description, by user, and other properties. There are a bunch of new items that allow you to filter the notebook tree, because in real life, you end up with thousands of notebooks by hundreds of people. So then they want to filter by things, or by age, or search for things, or you just want to see what you did in the last 2 weeks, for example, which is quite useful as well. We added the Jupyter kernel support, meaning we support any Jupyter kernels that are out there, and the Dockerization that I was just talking about. So, in short, I just wanted to have quickly show you rCloud, which was mainly designed to be collaborative and allow both data analytics as well as visualization. We kind of wrote it for ourselves because that really made our life much easier. Definitely make it much easier to collaborate and be able to just exchange results and work on projects much more easily. It enables the sharing, reproducibility, and discoverability. So if you're looking for something, you can find if someone else did work on a data set or a problem you wanted to start with. And it's really extensible because you can write things in JavaScript, and there are APIs that allow you to build on top of it. And there are several ways how you can add interactive graphics very easily, and it's all open source, so no strings attached. In fact, it's MIT license, so anyone can just take it and run with it. And it's fairly mature by now. We've been developing it for a while, and for several years we've been using it heavily internally. So thank you for your attention. Some acknowledgement of the authors. Gordon and Carlos kind of helped me a lot. I did all this work at AT&T Labs before I came here. I'm here only for 2 weeks now, so I hope I can continue actually working on rCloud, but it's definitely an interesting project. That's the official webpage. Because it's such a long round trip, I have a little setup here that I set up here in Oakland so that we can get faster to things. But thank you for it. Are they key bindings for Vim or Emacs? That's actually a very good question. They might be, because we're pretty much just using the ACE editor. So if there are, Gordon would be the right person to ask because he did all the front end. There is a chance. I know that on Mac actually, You can use the Emacs bindings because they are by default actually embedded in the web forms. But there may be, I'd ask Gordon. Can you save a pre-built image with the necessary packages and data pre-installed? Yes. So like I was saying, one of the options. So we actually have two ways that we showing people how you can do it. Or three if you count the regular way, which is you can just go, if you go to our source code, there is a script essentially that you can just run the script and it installs all the packages and everything you need and just sets up our cloud. We also have some pre-built VM images. They're actually a little dated today, but we have some on Amazon. We could update that as well. But the real, probably the easiest way is the Docker way, and you can, there of course you can just specify which packages you need, or if you have a project and there is this package that we wrote, which is our cloud Dockerize. It will essentially look up all the packages that you're using in the code, pull up the dependencies, build it into an image. You can specify data files that you want to include with the image, and then it will just deploy that. You can have essentially everything is super modular here. If you can, because we actually support, something I didn't show is we support multiple sources, so you don't have to have only one source of your notebook. So in this case, I was just using GitHub, but you can have your local image to be a source of code, and you can add a GitHub image, and you can add a Git image. So you can Git server. So you can essentially specify multiple sources, and for example, in the search, you can specify that you want to search all the sources, not just the one that's local to you. So yes, it supports, you can have multiple instances. They can share, for example, they can share the metadata and be completely separate images. They can have their own metadata and be separate images. They can share just the notebook store and have separate metadata. And we did have all of these different incarnations actually working as well, because some groups wanted to have their own infrastructure but wanted to share the notebook tree with us. Some people didn't want to share the notebook tree with us but wanted to have their own infrastructure. Some people wanted to use our infrastructure but not share the notebook tree. So yeah, all these combinations are actually possible. Can it cache long time running code blocks? It's a very good question. So it doesn't do it implicitly, and that was sort of a design decision because in part that we're dealing with very big data sets, so we wouldn't want to be saving things as we go implicitly. So we recommend people to do that explicitly, so that you define what you want to save, what are just temporary objects that you don't want to save. It's something we've been kind of going sort of here and forth, between different approaches, because for example in Jupyter just essentially stores the results and that's it. We intentionally don't store the results because we essentially rely on the ability that you can run the code is kind of proving that you have access to the data. So we are not restricting access to the code at all, because we want all this to be about sharing. So we want you to be able to look and find anyone else's code. Now that said, we actually do support private notebooks and encrypted notebooks if some people want to use it, but we prefer that people don't use it because then it's not discoverable and it's not collaborative. But we rely on the fact that if you're doing an analysis, it's the data that's the proprietary piece, it's not the code. So that if you don't have access to the data, then you cannot run the analysis. And that's why we don't want to sort of pre-share or pre-cache things implicitly, because let's say you have access to 3 data sets that you're combining in your analysis. Then now you get into this quagmire of figuring out like, okay, so I need all these accesses in order to reproduce this one. How do we know that? Right? There's no way to actually figure that out automatically. So that's why we have been kind of conservative and said, okay, if you want to pre-cache things, you have to do it yourself or declare what you want to cache. And that's it as far as the question goes. So yeah, thank you. Thank you for your attention.